Okay, let's look at the first problem which we have here. DC is the diameter passing through the center of the circle O. DC is diameter, O is the center, AB is tangent. AB is tangent. O is center, O is center, AB is tangent, AB is tangent, and what he has given you is that AB is 15 centimeter, AC is 7.5 centimeter. Find a radius. Find a radius. What we have done is we have assumed the radius of the circle to be r. We have assumed the radius of the circle to be r. I have joined O to B. O to B, the point of contact. OB will be the radius. We know the property which we have read. The first thing about the tangent we had read, tangent and radius are perpendicular to each other. Tangent and radius are perpendicular to each other. OB is perpendicular to AB. Tangent and radius. Tangent and radius are perpendicular to each other. That's what we know. Tangent and radius are perpendicular to each other. So this triangle OBA is a right angle triangle. Is a right angled triangle. It is a right angled triangle. It is a right angled triangle. In a right angled triangle, what happens? In a right angle triangle, we can apply Pythagoras theorem. And what is Pythagoras theorem? The square described on the hypotenuse should be equal to the sum of the squares of the remaining two sides. In this, the angle B being 90 degree, the hypotenuse is OA. The hypotenuse is OA. So OA square will be equal to OB square plus AB square. Now because what is the value of OA? OA is OC plus CA, or it will be R plus 7.5 whole square. R is the radius and 7.5 was given that. 7.5 was given then. Okay, OB is how much? OB is R square. AB is how much? 15 square. Now let us use the formula A plus B whole square. A plus B whole square. On the left hand side, A plus B whole square is R square plus 15R. Because 2AB, 2 into 7.5 will be 15. 15AB, 2AB plus 7.5 into 7.5 is, I've already calculated 56.25. When you will multiply them, you will get this. 56.25 is equal to R square plus 225. Square of 15 is 225 and R square plus 225. Now this R square will cancel with this R square, and we will be left with 15R is equal to 225 minus 56.25, which comes out to be 168.75. When you will subtract, you will get 168.75. So radius will be 168.75 divided by 15, which will come out to be 11.25 centimeter. So your radius is 11.25 centimeter. Radius is 11.25 centimeter. Actually, this is what we do the application. This is how we apply. What have we applied in this? We have used the property that the tangent and radius are always perpendicular to each other. Tangent and radius are always perpendicular to each other. Radius, this property is also important. OB is equal to OC. Radius is the same circle. OB is equal to OC is equal to R. We have assumed it to be R. We have assumed it to be R. OB is equal to OC is equal to R. So that becomes R point 7.5, and then we apply Pythagoras theorem and we get the value of R. R square in the calculation will cancel. You will get, you sometime you may get R square also, then you may get quadratic equation, and in the which one value may come negative, which will be cancelled, which will not be the solution. We'll have to see the solution has to be positive. Okay, now let's see question number 2. Question number 2 is, this is again difficult to make. That is what I said. It becomes difficult whenever you draw two circles. It is always difficult. It is always difficult. I have to make another circle. I'll try and make once again, otherwise. Okay, we got it. Thank God. Now these are the two circles which are touching each other at point P, which are touching each other at point P. Let me take out the scale. Let me take out the scale and show you. What do I want to show you? This is, I'll just tell you. Let me draw first and then there's a little bit of problem where the scales are not correct. This could be a trouble. That would be the problem. Okay. All right. What it says is that two circles are there whose I didn't need to do that center. I didn't need to draw the center. Two circles are given which are touching each other externally at point P, and PQ is a common tangent. PQ is a common tangent, and a tangent is drawn. QA and QB are tangents drawn to the other circles. What we have to prove is that QA and QB are equal. What is given is QP is a common tangent, is a common tangent, is a tangent where two circles touch. Instead of writing so long, I said that this is a common tangent. Common tangent means P is a common point. P is a point of touching for both the circles. So P is a common point. At P, a straight line is drawn PQ. So PQ is a common tangent. From QA and QB are tangents drawn. Are tangents drawn. Are tangents drawn to the circles, to the circles. Circles are of different size. You can notice that. The blue one is a smaller circle and black is a larger circle. So these are the two circles. From point Q we have drawn tangent QA and QB. We have to prove, require to prove QA is equal to QB. We have to prove QA is equal to QB. It's a very simple question. We read one of the theorems also, if you remember, that if from a point outside the circle, two tangents are drawn to the circle, they are of the equal length. From point Q, we are drawing QA and it should be equal to QP. QA should be equal to QP. Tangents from an exterior point, from an exterior point, from exterior point to the same circle, to the same circle. We have proved this theorem. We have proved this theorem for you that two tangents are drawn from point P to point to a circle, then they are of the equal length. QA is equal to QP. QA is equal to QP. Similarly, I would say that QB is equal to QP. The same reason. Tangents drawn from an exterior point to the circle are of the same length. So QA is also equal to QP and QP is also equal to QB. So QP is the common side. That implies QA is equal to QB. That means QA is equal to QB. We are using the property that tangent drawn from a point outside the circle to a circle are of equal length. QP and QA will be equal because Q is an exterior point and we have drawn two tangents to the circle, the blue circle in the figure, QA and QP. So they will be equal. Similarly to the black circle from Q, we have drawn two tangents QP and QB, and QP will also be equal to QB. So QP is equal to QA, QP is equal to QB, so QA will be equal to QB. So tangent drawn from a point outside to circle are of equal length. Using that property, we have done this question. Let us see question number 3. What is the question number 3? Question number 3 is okay. Again, two circles are there which are touching each other. Now, again, making that will be a problem. But let me try it. So, beginning is only wrong. Alright. Now let me draw another circle. This is always going to be difficult. This is what I said. It will be difficult. But I'll try again. No problem. Okay, all right, very close. We assume I'll show that they are touching each other. They are touching each other. These two circles are touching each other internally. They are touching each other internally, and from a point Q here, let me take the scale from the point Q here. Okay, no, this is done wrong. Okay, okay, okay. Yes. Okay, okay, let me draw this. Let me draw this common line. Okay, then let's take another color and draw too much time. Okay, okay, what we have drawn a figure where two circles are touching each other externally, internally at point P. Q is a point here. From Q, two tangents are drawn. Tangent to the smaller circle, that is QA, and tangent to the bigger circle QB. And again, we have to prove we are required to prove QA is equal to QB. Two circles touching internally nullly at P. Internally at P. Uh, QP is common tangent. QP is common tangent. QA and QB are tangents drawn. Are tangents drawn to the two circles. I'll write in the bracket red and yellow, red and blue circles. One circle is red, one circle is blue. For your understanding later on, so you don't forget what we are talking about. Now, what I have to prove is required to prove is QA is equal to QB. It is exactly on the same basis what we did the previous question. If two tangents are drawn from an outside point to a circle, they are of equal length. I will say QP is equal to QA. QP is equal to QA. Tangents drawn from an exterior point. From an exterior point. Exterior point. Similarly, I will say QP is equal to QB, the same thing. Tangents drawn from an exterior point. Tangent drawn from an exterior point. So, QA will be equal to QB, because both are equal to the same line. Both are equal to the same line, so obviously they are going to be equal to each other. They are going to be equal to each other. So tangent, the property which we are using is the tangent drawn to a circle from outside point to a circle are of equal length. Let me do one more problem. I have time for doing one more problem. Question number 4. Yeah, I can do one more question. He has given two concentric circles. Now again, they will be difficult to draw, but I will try and do it. Uh, okay, I will assume them to be concentric, but they're not looking concentric. Concentric means they should have the same center. They should have the same center. I'll assume their center is the same. The center is O. The center is O. What he's saying is that OA, the radius of the smaller circle is 3 centimeter, radius of the larger circle is 5 centimeter. We have to find uh, what is uh, okay. Let me draw the figure completely. Take the scale. Okay. Okay. Good. O P Q R. Now what he says is in this figure that these are the two concentric circles, concentric circles, circles having same center. It means having same center. When I say concentric circle, that means concentric circles are those circles which have the same center. It is not appearing to be concentric, which is the fault on my part, because I am not able to draw the correct figure. But the figures are never to the scale, because we are doing theorems, and in theorems generally the things are not to the scale. Uh, Radius of the smaller circle, the radius of the smaller circle, radius of smaller circle 3 centimeter, 3 centimeter, radius of circle, larger circle 5 centimeter, PR is tangent to smaller circle, and chord of the bigger circle, and chord of the bigger circle, chord of the bigger circle, chord of the bigger circle. Calculate PR. Calculate length of PR. Calculate length of PR. It is very simple because PQR is the tangent, OQ is radius, so it will be perpendicular. This angle will be 90 degree. This is 3 centimeter, and the larger circle OP is 5 centimeter. So I will say in triangle OPQ, in triangle OPQ, I would say that OP square will be equal to OQ square plus PQ square. OP is 5, 5 is square. OQ is 3 square plus PQ square. Or 25 is equal to 9 plus PQ square. Or PQ square will come out to be 16. PQ square will come out to be 25 minus 9, 16. So PQ will be 4, plus 4. The square root is always plus. So plus 4. PQ is equal to QR. PQ is equal to QR is equal to 4 centimeter. Why? If from this side also you calculate, it will come out to be, and these two triangles are congruent triangle. OQP and OQR will be congruent also, and if you apply the same thing, you will get 4 centimeter. So PR will be equal to how much? PR will be equal to 4 plus 4, that is 8 centimeter. We wanted to find the value of PR, the chord of the bigger circle, which comes out to be this much. We have got PR is equal to 8 centimeter. We have got PR is equal to 8 centimeter. That is it. We have exceeded the time, so I'll stop recording.